Hey guys, this is Mr. Grice for Algebra 2, Unit 3.4 Notes, Day 2. Today we're going to be talking about graphing absolute value functions. Our learning target today is to be able to graph absolute value functions and their vertex, max and min, and transformations. So today we're going to be talking about more different types of just vertical stretches, vertical shrinkage, when something is shrunk, um, looking at the average rate of change, and just more reflection type stuff. So let's go ahead and get started. Now, we talked a lot about the parent function. Okay, the parent function is just the basic graph. And we're talking about absolute values, which make the V. Okay, so in our basic function, the vertex is 0, 0. There's no reflection. And so let's talk about the average rate of change. Remember, the average rate of change is like the slope. So when we're looking at 0 to infinity, okay, 0 to infinity is everything on the right side. You can see that we are going up 1 over 1, up 1 over 1, up 1 over 1. So my slope for the right side is a positive 1. But on the left side of the graph, which is the negative infinity to 0, our slope is actually going down 1 over 1, down 1 over 1, which gives us a slope of negative 1. Now, when we're looking at our next function, the graph looks a lot different, okay? And it's getting stretched, okay? Another word to say is that it's getting more narrow than the parent function, okay? So the big difference is the number that is out front, okay? So it's a positive 2, and let's look to see what happens when we're at 0 to infinity. Instead of going up 1 over, or up 1 over 1, now we're going up 2 over 1, up 2 over 1. So my average rate of change is 2. But now when we're looking at the opposite side of the graph, the negative infinity to 0, I'm not going up 1, I'm going, or up 2, I'm going down 2 over 1, down 2 over 1. So my slope is negative 2. Okay, so that number out in front determines whether if it's going to get stretched like it did in our middle example, or if it gets shrunk, and that's when it's more wide. Okay, so what do you think it's going to be from 0 to infinity, the right side? Yeah, we went up 1, right 2, up 1, right 2. So our slope is 1/2, our average rate of change. And then the opposite direction from negative infinity to 0, we're going to be down 1 over 2, down 1 over 2. Okay, so if you notice, when it was a whole number, we got narrow. When it was a fraction, it got wide. And we're going to see that as we move on. Okay, so number 1 is saying identify the specified characteristics of each function and graph it. Now, for number 1, we have 3 times the absolute value of x plus 1. The first thing I notice is that there is no reflection. Okay, so if there's no reflection, our graph's going to look something like that, and we can see the min. Now, when we're finding the vertex, we take the opposite of the number in here, which is 0. So I can't really take an opposite of 0. And the number out here stays the same. So our vertex is 0, 1. So our transformations, we would say that there's no horizontal shift. Our vertical shift right here, that's telling us to go right one, okay? And the last thing that we're going to talk about is our rate of change, okay? And that rate of change is saying that it is being stretched 3 units vertically. Okay, so there's no I'm sorry, that right one, Mr. Grice. Please change that. That was because that was our vertical shift that we went up one. Ay, ay, ay. Okay, so we're at 0, 1. Okay, and if it's a vertical stretch, so instead of going up 1 over 1, I'm going to go up 3 over 1, because that's what our rate of change tells us to do. Okay, and we do that in both directions. And when you're all done, you use your straight edge to graph your line. And there you go. Let's redo that one, Mr. Grice. There we go. And make sure you have arrows. All right, let's look at the next one. So is there a reflection? That's where I'm looking out front. It's positive, so that means no. So that means I can see the min. So here we take the opposites. That's going to be a -2. And the number out front stays the same. So I've got -2, 1. So talking about our transformations, that this is going to be shifted left 2 and up 1. Now let's look at our slope. Our slope is 1/4. That's a fraction, so we are going to get shrunk 1/4 units vertically. So I'm going to go to -2, 1, and then we're going to go up 1 over 4. So up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And we're going to do that in both directions. 1, 2, 3, 4. And then we're going to use our straight edge to draw our lines. And there you go. So why don't you pause the video and see if you can just answer the questions on 3, and we'll talk about the transformations together. Go ahead and pause the video, and good luck. Okay, so the negative means that it's going to be reflected over the x-axis. Oh, here we go. And then I drew my little picture, and I could see that the vertex is the max, it's the highest point. The -1, we take the opposite, so it's +1, and the -5 stays the same. So talking about the transformations, the first thing that I know is that it's going to be reflected, and that's over the x-axis. Now let's talk about our shifts. Okay, this graph is shifted right 1, and it's going to be shifted down 5. All right, now let's look at that -2. That 2 is telling me that it's going to be, stretched. It's going to be more narrow. So it's going to be stretched 2 units vertically. So let's go ahead and graph that. I have to go right 1, down 5. And then instead of going up 1 over 2, we're going to go down 2 over 1. So I go down 2 over 1, down 2 over 1. And we're going to do that in both directions. Okay? And then use your straight edge to line everything up and draw your graph. Okay? All right, let's go and flip it over. Now on this side, all we have to do is compare the given functions to its parent function by describing any transformations, shifts, reflections, or stretches. Okay? Use the vertex to help you describe the transformations. So for these ones, we don't have to graph. We're just looking at what the function tells us to do and then to describe it. So remember, the first thing we always check, is there a negative out front? Because that's our reflection, so it's no. And since we know that it's no, we know that the vertex is going to be the minimum. Now we have to find the vertex. We take the opposite, which is a +6, and the 7 stays the same. So that vertex is 6, 7. Now, describing it, the vertex tells us that there's going to be a shift. So we're going to go right 6 and up 7. Okay, and now we're going to look at that 5. So that 5 tells us that this is stretched 5 units vertically. And that's what we have to write because there is no reflection. Okay, so remember the vertex tells us if we have to be shifted right or left or up or down. And then the number out in front tells us if it's going to be stretched or not. All right, number 5. So, do we see a negative out front? No. So we know that this would be going up and that the vertex would be the min. Now, what is the vertex? Well, once again, we take the opposite. So that's going to be a -3. And then the -9 stays the same. So we know that this is shifted, and it's going to be shifted left 3 and down 9. Okay, and that's before we were saying, oh, this is down and this is left. Okay, just know that left 3 means you're actually going 1, 2, 3 to the left and then 9 down. Okay, now look at this. We have our fraction 1/8. All right, so it's not getting stretched. This time it's getting shrunk 1/8 units vertically. Okay, and we get the 1/8 because that's the number that's out in front. All right, number 6, why don't you see if you can do the entire thing by yourself? Go ahead and pause the video. Good luck. Okay, so there's a negative out front, which means that, yes, it's reflected. Our vertex was 3, 0. Well, where do we get the 0? Because we would take the same number out front, and there's nothing out there, so it's 0. So our vertex is the max number because it's reflected. In our transformations, it's reflected over the x-axis, it's shifted right 3, and then it's stretched 2 units vertically. Okay, so now let's do all of that from a graph. I know, this might be a little bit harder. So let's take a look at our first question. Is there a reflection? Well, yeah, it's upside down. It's opening down, okay, because that's what we would say. And if it's like that, we know that the vertex is a max. So my vertex is right here. So what is that point? Well, we went left 3, and then I went up 1, 2, 3, 4. Okay, so we know to start with that there was a reflection over the x-axis, sorry, that this was shifted, and the shifted it was left 3 and up 4. Now, the last thing that we have to talk about is whether there was a change in the slope. Was it stretched or was it shrunk? So let's find out. Down 1 over 1, down 1 over 1, down 1 over 1. And if you look at that, that's kind of how it's going both times. It's 1 over 1. So when it's 1 over 1, that means there is no, we would say no vertical. There is no vertical stretch or it being shrink or shrunk, however you want to say it. All right, our next one. So, is there a reflection, yes or no? No, because our graph looks like that, and when it looks like that, that is the min. So here's my vertex, and what is the vertex? Yeah, we went right 1, and then we went down 2, okay? So there's no reflection. We went, this was shifted right 1 and down 2. Now let's look at our slope. I already tell that it's not being stretched. Yeah, it's being shrunk, okay? So what we have to do is figure out how is it being shrunk. So we went up 1 and then 1, 2, 3, 4. And let's see, is that true in both cases? Here's my point. There's down 1, 1, 2, 3, 4. And remember, it's going to be opposites. One time it's positive 1/4, and then it's a negative 1/4. So is there a transformation here? Well, yeah, okay. It's being shrunk 1/4 units vertically. All right, last one. Okay, so is there a reflection, yes or no? No. Okay, that's how our graph looks. It's opening up, so the vertex is a minimum. Speaking of vertexes, where's it at? Yeah, right here, which means we went left 1, and then we went down 3. So when we're talking about our transformations, the vertex was shifted left 1 and down 3. Okay, so last thing, let's look at our rate of change. So I think those are my points. So going to the right, it was 1, 2, 3, 4, 4 over 1, and that means it'll be the 1, 2, 3, 4 over 1. Good. So that means that this was stretched 4 units vertically. And that's it. Now, your homework is the 3.4 practice B. It's going to be graded, so make sure you can complete both sides. Okay? Now, if you have any questions or you need extra help, please come see Ms. Carranza. Oh, excuse me, just had to sneeze. So if you need help, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra 2, Unit 3.4 Notes, Day 2. Thanks for watching.